Alright, let's look at the compositions of functions. Alright, compositions f of g of x is defined as simply f of g of x. So g of x is plugged into the function f of x. Alright, and its domain is going to be a little bit tricky. So if you want to find the domain, say domain of f of g, right? So in order to find that, we have to look at a couple of things, right? So of course, g of x has to make sense. So number one condition is x has to be in the domain of g, because otherwise g of x doesn't make sense. All right, and number two, since we are plugging in g of x into the function f, we have to make sure that the g of x is in the domain of the outside function, which is f. All right, that's how you find the domain of f of g. All right, so let's look at this example, number 35. All right, so f of x is equal to x plus 1 over x. So domain of this guy is fairly easy to find because here we have to make sure that the denominator is non-zero. So domain of f is x cannot be equal to 0. All right, we have that. And the domain of g, same way, we don't want x plus 2 to be 0, so x cannot be negative 2. So domain of g would be x is not equal to 2. Right? So all real numbers except negative 2. Alright, so let's find the f of g first. Right? F of g, so what we do is, remember the definition is f of g of x. Right? So what we do is just plug in f of, right, g of x is x plus 1 over x plus 2. Right? And then this is going to be equal to, all right, so we just plug in x plus 1 over x plus 2 into this function f. So you're going to get x plus 1 over x plus 2 plus, we take the reciprocal of that, so it's going to be x plus 2 over x plus 1. All right. If you want, we can put them together and look for a common denominator. I think this is fine for now. All right, but if you want to find the domain of f of g, all right, so first we have to make sure that the x is in the domain of g of x. All right, so domain is, so we have, so x has to be in domain of g, which means that it tells you that x cannot be equal to 2. Oh, sorry, negative 2. Right? And 2, we have to make sure that the g of x in the domain of f. So we have to make sure that the x plus 1 over x plus, oh, actually, maybe I should write that here. First, we have to make sure that the g of x is in the domain of f, which means what? So we have to make sure that the x plus 1 over x plus 2 has to be in the domain of f. Domain of f is all real numbers except for 0. So it cannot be equal to 0, and which means that x plus 1 cannot be equal to 0. Which means that by subtracting 1, x cannot be equal to negative 1. All right, so we know that the domain of f of g is going to be, all right, we can't have negative 1, we can't have negative 2. So it's going to be negative infinity all the way to negative 2. We skip negative 2. go to all the way to -1. Then we skip -1, then finish up to positive infinity. Right, so this is the domain of f of g. Right? Right, let's do the other way around. G of f of x. Right? So remember that we plug in f of x into the g function. Right, so f of x is going to be x plus 1 over x. Right, so we plug this into a g function, x plus 1, so x is replaced by x plus 1 over x, and a plus 1 over, and we have x plus 1 over x plus 2. Right, since I don't like having a fraction inside a fraction, I'm going to just multiply top and bottom by x, just my personal preference. So this is going to be equal to x squared plus 1, actually, and 1 times x, so x here. You have x squared plus 2x and plus 1. Alright, actually it looks kind of nice on the bottom, so I can actually factor out x plus 1 squared, and then you have x squared plus x plus 1. Alright, how about the domain of g of f? Alright, so we have to make sure that we have to make sure that the x is in domain of f. Right? So which means that, let's see, domain of x cannot be equal to 0. Right, we got that. And 2. Right, we have to make sure that the inside function is f of x has to be in the domain of g. Right, this is kind of interesting. So f of x is x plus 1 over x. Right, this cannot be equal to, right, domain, so -2. Alright, so this is actually a quadratic inequality. So multiply through by x, we have x squared plus 1 not equal to -2x. And then we can just add 2x to both sides. So you have x squared plus 2x plus 1 not equal to 0. And which gives us, right, we can factor that out. So x plus 1 squared is not equal to 0, which means that the x cannot be equal to -1. Alright, so we know that x is not equal to 0 and x is not equal to -1. So the domain of g of f is going to be, right, so all real numbers except for -1 and 0. So it goes to -1, skip -1, go to 0, skip 0, and go to positive infinity. Alright, so this is the domain of g of f. Right, so you have to make sure that the second one is going to be the inside, and the first guy is going to be the outside function. So g of f, f is going to be the inside function, and if you have f of g, and g is going to be the inside function. All right, that's it. I hope that this was clear.